Hello friends, I welcome all of you. In this video, we'll talk about IP header. So header is something that you add additionally. It is just that you have a package of document and you want to courier it or send it to someone else in some different location. So you put that document in envelope. That envelope is header. You write in certain details so that it can be delivered, right? This is the main functionality of header. So here we are talking about layer 3, that is IP header. You know that the OSI model, application layer, presentation, session, transport, network, data link, physical. This is layer 2, 3, 4, 5, 6 and 7. So we are here right now. So transport layer sends segments or user datagrams, right, over to network layer. So whatever transport layer sends over to network layer, let's say it sent this segment. So this segment will become payload at the network layer, and it will add an additional header. This is the header which we want to talk about, the IP header. The first question is, what is the size of this header? Answer is 20 byte to 60 byte. So it resembles TCP in terms of size. 20 byte minimum, 60 bytes maximum. It means 40 byte of optional fields can be added. That is why I mentioned it here. So you see from here till here, it's a header, and this one is your actual payload. This is the field number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Total of 14 fields. 15th one is optional. So let's start the discussion. This is the field number 1, which is of 4-bit. So if you add all of these fields, the answer will be 20 bytes. I can add like 4-bit plus 4-bit, 8-bit plus 8, 16, 16 plus 16, 32-bit in this line number 1. And this identification, which is for fragmentation, 16, 17, 18, 19 plus 13, 32-bit. Again, this one is 8 plus 8, 16 plus 16, 32-bit. Source IP, 32-bit. Destination IP, 32-bit. Optional, 40 bytes. If you convert these into bytes, 4 bytes, 4 bytes, 4 bytes and 4 bytes. 4 plus 4, 8, 4, 12, 16, 20 plus 40, 60. Maximum 60. Alright, so this one is what I wanted to explain. So this is a version 4-bit. So are we using IPv4 or 6? So if it is IPv4, how would you write IPv4 in 4 digits, 4 bits? 4 will be like 0100. Okay. If it is IPv6, then it will be 0110, right? But why do we need 4 bits for that? We could do the same thing with 3 bits, right? But actually we don't know if there will be IP, let's say v10 in future. Ideally I don't think so, but yes, they may have a plan for that. That is why they have kept 4 bits here. This is the version in 4 bits value, just to mention that version of this. And what is this HL? This is header length. Header length 4-bit again. So if you are using 20 byte, which is the minimum size, divide by 4, this is the formula. Answer will be 5, and write in bits format. It will be like 0101, right? And if we are using 40 bytes of size total, divide by 4, answer will be 10. Convert that into 1010, which will be binary. So it will be mentioned here. And for 60 divide by 4, answer will be 15. The all values will be 1111. You can mention it here. So this is done. Now this type of service, this is the 8-bit field. It is mainly for quality of service, which means precedence. You want to prioritize the traffic based on the type of application, or as per maybe you want it, like we want high precedence to voice traffic or video traffic or business critical applications, right? Or financial applications. So you can use this 8 bits to do this thing. All right, means you want certain traffic to go on critical basis, on high priority. So for the IPv6, this 8-bit is known as type of service. This is mainly for IPv6. And if you have IPv4, then these 8 bits will be known as DSCP plus ECN. Let me explain you. So if for let's say IPv4, it will be DSCP, which will use 6 bits, plus ECN, which will use 2 bits. So what is this DSCP? Full form is differentiated services code point. Again, the purpose is same. It is for giving precedence, that is priority, but it will use 6 bits in that. All right, for precedence, priority. And for the ECN, that is explicit congestion notification, there will be 2 bits. So if both bits are, let's say, set to 1 and 1, it would mean that there is a congestion right now in the path, packet is not delivered, and this notification is being sent to source. Means it is telling the source that, see, you sent a packet, there's a congestion in the path, and I'm stuck, but I am not dropping the packet. This is the meaning of these 2 bits ECN, right? And the 6 bits, there will be values for each of these applications. So once you reach at CCNP level or at the QoS section, then you will understand this thing. All right, so this DSCP 6 bits plus ECN in IP, this one V4. And just for your information, if you want to know what are the bits for the IPv6, then I must tell you, let me tell you, the first 3 bits, these are known as priority bit. Means these will be used to precedence the traffic or prioritize, and the next 5 bits will be like, 4th bit will be known as delay bit, then throughput bit, then reliability bit, cost bit, and this one is reserved or optional. It is always 0. So by marking this 4th bit as 1, we are telling that we want less delay. It is our desire. So treat this traffic accordingly. Means this is for urgent traffic. I want it to be delivered at much higher speed. Ultimately, this delay, it depends upon the media, router, and there are many contributory factors. But yes, this is, you can mention your requirement, desires, right, by enabling this field as 1. So T means throughput. You want high throughput. You want more data to be sent at less time. Then you can make this value as 1. And this one is reliability. You want traffic to be sent reliably. Then you can make it 1. And for C bit means you want less cost. You want shortest path for the traffic to reach at the destination. So I took much time to explain, but you can choose to ignore all of these things if you want. Otherwise, it's good for knowledge, right? So this is about this thing. And total length, the entire length of IP packet, including the header. So 16-bit field, if 2 raised to power 16 equal to 65535, this can be the maximum size of the IP packet, which also includes the header. So let's say if the header is 20 bytes, and then for the payload the value will be 65515. Okay, if the size is 60, then the value you can make it like 65475, maybe 65, like 465. This one will be the value of payload. This section is part of fragmentation. I'll explain in next video because it will take much time. Let's move further. So this TTL is time to live. Time to live. So it is for loop avoiding mechanism. Let's say this is source, this is destination, this is let's say there are many routers, right? You send packet to this router and it sent it to further to this router. Let's say router 2, R2. This is R1, R3, R4, R5. R2 sent it back to R1 because of some routing issue or wrong configuration. Then R1 again sent it to R2, R2 sent it back to R1. This process kept on happening. So ultimately we need to stop this loop. This is the perfect example of routing loop, right? We must stop it. So what we do is we use this 8-bit value which will stop the loop. Okay, so 8-bit means 2 raised to power 8 equal to 255, the maximum value. Okay, all ones, 1 2 3 4 5 6 7 8. If you convert, the maximum value of TTL can be 255. So it means there can be maximum of 256 hops. 0 plus 255, right? 0 to 265. The value can be 255. That would mean every time a packet crosses or exits a router or layer 3 device, the value will be decremented by 1. Let's say the TTL value is set to 8. Okay, so it exited the router, the value will become 7. Then second router, it exited, the value will become 6. Third router, 6 minus 1 equal to 5. And then there is a let's say there is the loop, right? So loop kept on moving packet back and fro. So ultimately if the value becomes 0 at the end, then the packet will be dropped. So this is like a mechanism to stop the loop. So once the value is 0, the packet will be dropped. So ideally it means how many hops your destination is. This is TTL value. This protocol means which transport layer protocol are you using? Please tell us. So if you are using TCP or UDP, or you are using IGMP, ICMP, OSPF, you have to specify. There's a value. There's a list of protocols maintained by this body of networking. You can see that. Okay, I'm just explaining you. And this checksum value, you know, it is basically to identify any changes in the packet during the network movement. Alright, so initially when a packet is prepared, a value of checksum is derived. Some formula is there. Let's say value is AAA, and once the packet was delivered at destination D, if the value remains AAA, it means packet was intact, else it was modified. So this is the purpose. Source IP, I told you IP address is 32-bit. It will be in 4 octet, like 11.1.5.1. Destination IP can be 202.5.11.1, right? So these this is a 4 bytes. So these are the fields, and this optional is 40 bytes field, and this one is your actually payload. Okay, So I've explained you all of the fields except these fields, which I'll explain then in the next video, right? Because it's a bit long, else you lose track of it. So I'm giving you detailed information. If you don't like it, just don't worry, just ignore it. Just understand the main things, the at least the names of these fields, the size of the IP header. Okay, you don't need to remember, but yes, it's a good thing. These things will help you passing the interview. Okay, thank you so much for your time. Have a nice day.